Okay. Yes, we are live. Okay, so today, this Sunday morning, we want to try ICPC World Finals. It just happened 3 days ago, yeah. Just happened 3 days ago at Dhaka, Bangladesh, and it's university level programming competition. And I was there actually 2007. I was in the World Finals Tokyo 2007 without coding a single thing. How do you win competition programming competition without coding a single thing? Yeah. Anyway, 2007, now it's 2002, so 15 years ago. Wow, 15 years ago. Now we are going to try, ya Mas, ya. We want to try some of the problems. Okay, so it is happening in Dhaka a few days ago, and the winner was MIT. If we look at this final result, this should be final, right? Yeah, this is final standings. The final result, number one is MIT, followed by Peking University, Beijing basically, yeah, Peking University, and University of Tokyo, and Seoul National University. Wow. Oh, this is interesting. Hold on. Is this really the final result? Huh. Okay. Oh, yeah. I thought the winner was from, you remember, it was from Russia, right? This one, right? Was it not this one?
Yeah.
Ah,
It should be there for Russia.
yeah, I thought it was this one. So how do we check? Uh, Results. Is this the results? Oh, the result. Yeah, okay. It is the result. Ah, what did we watch yesterday then? The YouTube streaming. Some error or what? Anyway, very strange. Wow, this is very surprising, yeah, Mas. Yeah, if we look at it, the top is MIT, maybe not so surprising, but the next three are all Asian universities. So the gold medal is actually dominated by Asian universities: China, Japan, and then Korea. Wow. Anyway, so we are going to try the problems. There are 12 problems here, A until L. And if we look at the result, yeah, if we go all the way down, teams that can only solve one tends to be H. Problems H is the one that I think is the easiest, right? I mean, teams that can only solve one problem, they solve problem H, but not other problems. So we will try H. And maybe after that, the second easiest is J, yeah? You think so? You are on mute, Mas.
J.
Yeah, right.
Yeah.
J, H, and then J,
C,
and
D,
then
E, F, G.
probably L, yeah? Yeah, looks like L, yeah?
Yeah.
Maybe
H
L
J
and then C.
H
Yeah.
J
So,
F.
yeah, HJLC. Yeah. I mean, if we can do 4, it's already very good, but I don't know. Because 4 will put us, solving 4 will put us at rank 70. Rank 70. So I think if we can solve 4, that will be already amazing. But let's aim for at least 1 today, which is problem H. Okay,
Oh,
so how do we go there? So we can go to this judge.icpc.global and then sign up. Then we can get the problem statements here. Problem statement H. Problem statement H. Uh, yeah, this is the problem statement. Okay, you got the problem statement with you, man? You got the PDF?
I got it.
Yeah, I printed also. Let me take it.
I think no problems in the place of unknown.
Yep, I got a printed one also. Okay, let's read the problem.
The tax circuits are where other such to arrange them into a sequence so that the resulting work has a properly nested. You just arrange them.
Yeah, let me know after you finish reading this
From 1 to n such that the concatenating the
while I'm
strings and
checking the comments.
z odd word describes it. What? 1 to
Yeah, let me know once you are done reading this. I've read this problem earlier before we start. I think it's doable. I believe you should be able to do it.
I don't understand what we're supposed to print.
What you are supposed to print is
Oh, actually,
the
yes.
permutation.
Oh, okay, okay. Now I understand.
So in this problem example, yeah. Okay, so let me also explain the problem to the audience as well, yeah. Basically, we are given a bunch of opening bracket and closing bracket, right? So imagine there used to be one long opening bracket, closing bracket sequence that are valid, and we know what the open bracket and closing bracket valid means, right? You pair it up with you can match it. You can match the opening with the closing, right? Um, so imagine you used to have that very long. Imagine it's like in rock tablet, clay tablet like that, and then it broke. It broke into n number of pieces and like scattered around. So you are asked to put back those pieces in such a way that it will become valid. If there is multiple possible permutation, if there are many possibilities to permutate the sequence, then you can output any. So in this case, in this input example, right, we are given this two sequence, this one and this one. So for this to be a valid sequence, we need to put number 2 first. We need to put this one first and then followed by this one. So if I do a copy paste, right? If I do a copy paste and okay, how do we do this? Oh, over here works, right? I can put it on the top here, right? Now, if I do it like this is actually a valid sequence, right? This is a valid sequence. This is in inner, which is, yeah. Yes, this is a valid sequence. You got it? Understand
Yep,
problem?
yep.
Yeah, and if it is not possible to rearrange into a valid combination, then we output impossible instead. Yeah. And some other example, like this one. This one is straightforward. It's impossible to rearrange this into a valid sequence. There's no way. Right? Yeah. This one, we put one first, followed by 5, followed by 3, followed by 2, followed by 4. Okay, looks valid. All right, you got it? Okay, what is your
Yep, yep.
ideas? Now I'll go to your whiteboard.
My idea is for each string, we have a map, right? We have a map that whose key is every string, and it points to how many brackets are not yet closed or opened. How do I?
Yeah.
It's like, for example, this string, yeah. For example, this string like this, right? In this case, I will say the number of close parentheses that doesn't have a pair will be 2. Then the number of open parentheses will be 1, right? This one and this one, right?
Okay. Yeah.
Yeah. So yeah, this is just a loop. Then what do you call that? We just loop through. We find one element that has 0 closed parentheses. We find a string that has parentheses closed pointing to 0. And then after that, we find parenthesis open is what? For example, x. Then we find another one whose parenthesis close is equal to x. And then we repeat the process again and again.
I see.
Yeah.
Okay, that's a good idea. Okay, go ahead.
Then now,
I
it's
get what
just
you mean.
now is the
Yeah.
time limit. Then, for example, if the current string has uh if the current string has open brackets of x, right? And there are two strings A and B that have both of them have close bracket of x also, right?
Mm-hmm.
Then you have to try both of them because you don't know which one you will do. Which means that for every choice you have another option. So it's basically O n squared. This is O n squared, right? This
Okay, but this actually means we make an assumption that every two consecutive items will complete each other, but it's not necessary, right? Like the opening one can be completed by combining two or three other sequence that
oh
follow.
yeah, oh yeah, that is oh yeah.
Yeah, but I think you got the first step correct. So every piece we can have two numbers, right? One is how many unmatched open bracket, and the second number is how many unmatched closing bracket. And we have to start with the one that do not have unmatched closing bracket, right?
Yep.
The first component has to yeah, I agree. Oh, you may want to share your coding screen also if you already start coding.
Don't show this. Entire
The VS
screen on.
Code.
Yeah,
Up to
entire
you.
screen.
Entire screen, okay, I guess. Entire screen
It
easier.
doesn't show test code as an option.
Yeah.
So it will be map of long to let's just make two. So MML closed and open, right? Uh, then how do we check? Yeah, then here we need to use stack, right? We need to use stack. We can have a stack of a bool. We can have bool, st. Then each character in S, we check if how do you say this? So the bool is basically means that zero or false is open, one is closed. Yeah. All right. It means or actually can we just make a stack of char? That's easier, right? Then char current equals to s dot pop, s dot pop. Oh, forgot st. Right. Then if current equals to z and ch equals to z, current is yeah, this is correct. If current is that, then we continue. Okay. Do we continue? No, we have to pop. Oh, but it's already popped. But then I'm not supposed to have that pop over there. Yeah, but it is short. Wait, what's wrong? Okay. If current is open and that is closed, if they're both the same, open, then we just add two times. Just add two times. If current, that means that means they are. It's either open. It's either like this or like this. Oh no, like this. Or like this. Or like this. All of which are invalid. So we can just do st dot push current then st dot push ch. Yeah. Right. Oh, but we also need to map it. Oh yeah. So then now, oh no, that's after the. Then we map. What do we map? We map the closed of I is equal to. Oh, now we have to look through. LL closed equals to 0, open equals to 0. While not st.empty. Okay. Yeah, that is correct. Then map of I, closed of I is equal to CL, open of I equals to OP. Right? Yeah, this is the. Now we have the values, the number of unfinished open and close brackets.
What happened in the beginning?
Hmm?
In the very beginning, when you just starting?
It's CNN. What do you mean?
Okay, try to see out first. Try to just see out the create the test case and then try to just see out the numbers.
Okay. Test case. No, it's not that. 2-1.
Yeah, but try to just see out the number. Ah, see, it's already error. Six F. I think this is you are accessing a null pointer. Something null.
A null point. Oh. Oh. Oh, I see. I see. If st.empty, st.push ch, and continue. Okay. Just to double check.
See out, yeah. Just see
Now,
out the
cl op. Is that correct? Two close first. Close first. So 1, 2. Yeah. Then 0 to 2. Yeah. Yes. Close then open.
Okay. Yeah. Okay, good. First step is done. So now you got the maps. Now what do you do with the map? What do you do with these numbers? It doesn't have to be map actually, right? I mean, it can be just array. It will be much faster if you just make it integer array.
Oh yeah. Okay.
Yeah. Size n, right? You know the size anyway already. Yeah.
Yeah. Then now we find one with closed equal to 0. Closed I equals to 0. We find I. No, we find I where. Yeah, closed I equals to 0. Not open. Yeah. So if CL equals to 0, LL start equals to 0.
No, st, you already use st. Variable
Uh,
name st you already use.
-1. Start equals to I. I think that's all right. Then if I is equal to -1, CL -1 and 9.
See out impossible.
Oh, yeah. Let's
Try
test the.
the test case that is impossible. Yeah. Try this one.
Hmm. Oh, of course. This is impossible for another reason. We try another test case. The test case three. Two. Two simpler. That then there is. Then this should be impossible. Sims was 3 4. Yeah.
Okay.
15334. Okay. Then what do we do now?
So now you have n pairs, right? You
Yep.
have n pairs of numbers, unmatched opening and unmatched closing. Now you need to find the permutation such that what?
Find the permutation. Wait, let me try something. If we have this, and we have is it
So in your first processing, you sort of remove the matching pairs already, right? So you already removed the first two characters in this case, right? You can strike that out, right? Yeah, that becomes 0 2, right? Yeah. And you know you can match these two because actually, why
oh
don't you do this? What if the closing is a negative number?
yeah, then you sum up and it has to no, but
What happen if you have something in between? Yeah.
yeah. So if we find a pair that works, then it's just
Time limit is 6 seconds. Surprisingly, time limit is 6 seconds for this.
oh, but that could it could be made up of many. Oh yeah. That I have an idea. I think really. Let me look at it. We have it as a negative number. We find those that sum up to zero. We get the open as a negative number. We find pairs that sum up to zero, and then we have the start and the end be the start and pair and the pair of start, and then we find another pair. We put it in between like that. Yeah, but then the
Oh,
problem is there could be what was the problem? Oh yeah, there could. Oh wait, no. Then we still. Yeah, again now the problem is finding a pair because the pair. For example, if I have one string as 20 close and open, then I have another as 01, then I have another as 01. I can't have 20 and 01 alone. I need the other 01. That's the problem. How I get the 01. And when the numbers get bigger, there are more possibilities. Which means that use DP. No, there's no use DP. There are too many pairs. Okay. So this start is one with zero opens. But that doesn't. ICPC is not subtask by subtask, right? It's just
Nope.
you
Nope.
are correct on.
Yeah, make it or break it. Either you solve it or you don't.
Oh,
That's ICPC style, different from OI, IOI and OI. This is university level. Yeah, that's why harder. But your match and unmatched, sorry, your unmatched closing and unmatched opening will always be like
always me.
um, if you clean up everything, right? If you remove the valid portions without changing the validity of the segment, right? It will always result in like two crescents situation, right? All the closing brackets that is unmatched followed by all the opening brackets that is unmatched, right?
Yep.
Yeah,
Yeah. Yeah.
yeah. So that means your approach is okay. Your approach of mapping into two numbers is valid. So we have all the map now. We have all the pairs. Now the question is, what do we do with those pairs? What is valid? If we combine everything and it becomes valid, what does it mean? So I'm thinking like this, Mas. What if closing bracket is a negative number, opening bracket is a positive number? So when they cancel each other out, then you get a valid sequence. Is that a fair reduction of the problem or analysis of the problem, or do I miss something?
Yeah. That is fair. Like, but the problem is it's not necessarily a pair. Doesn't have to be a pair.
Okay, give me an example in which it won't be a pair.
For example, we have a string where closed and open is 2 0, and then I have two other strings where closed and open are 0 1 and 0 1. 0 1, yeah, right? I can't just
Yeah,
have 2 and 2 0 and 0 1. I need the other
yeah,
0 1, make it valid.
yeah. So you have to continue canceling, right? You have to continue canceling.
Yeah, and same can also happen for the start, right? It won't necessarily, you may need to, no, you may need more than,
So
yeah,
yeah,
okay.
okay. So it doesn't have to be immediate, right? It may be combination of multiple. But you start with uh let's say x0. You have to start with 0, right? The closing must be 0. So let's say you start with x0. Now you have to find the subsequent segments such that it can reduce x, right? It can reduce x, but it cannot go to negative number. You cannot reduce x until it become negative. But you have to reduce x. Um,
Yep, yep,
yeah,
yeah, correct.
you have to reduce x.
But
Yeah, you have to
sometimes,
reduce x until everything is sum up to 0.
yeah,
So actually checking if it is impossible is very easy. Yeah, if we just sum up everything,
yeah,
yeah,
if
right.
you sum,
You can just sum up everything, and they have to sum up to 0. If it is
oh, yeah,
not summing up to 0, then definitely impossible. If it sums up to 0, is it definitely possible?
yeah, definitely. Yeah, of course.
Yeah. So maybe we use close as a negative number, so you can do close minus minus instead, right, over there. Line 83, if you say close minus minus, oh yeah, well, okay, up to you. Whether you want to sum or you want to minus, okay, up to you. Okay.
Okay, so if start
Yeah.
equals to -1
It,
or sum equals
yeah.
not equal,
Yes. Correct. Correct. Yep. Now
why is
you
it?
pass the original test case also, right? Yes.
Why is this now
Wait, the
impossible?
first one,
It's all impossible.
the,
That's weird. This should be 2002 minus 2 equals 0.
you wanna print the array, open and close array.
Okay.
You start with close
Oh,
first, yeah. Is it not on?
yeah. I know my problem.
Oh yeah, because it's
Yeah, because
array, we need to mem. Yeah.
we also do that. Memset
Yeah, the first
close
step in the beginning, so it was okay.
close of close if open.
Yeah.
Yep. Okay, now 0. Yep.
Okay, so
Yeah.
the impossible is passed, yeah. Okay, so we solve the impossible now. Now, for the possible cases, essentially every segment can be represented by just one number, right? Actually, right? Because if you have, oh no,
Difference
you
in
cannot, because you cannot
yes.
minus, you cannot reduce until negative, right? You cannot. Yeah.
Yes. What if we have
Is this greedy then? Can we use greedy? It's like we would want to have the as many opening brackets in the beginning as possible, right?
and then as oh yeah.
Right? It's safest that way.
Yes, yeah.
Yeah, yeah,
So we
yeah.
find
Then it's just
we
greedy, right?
substitute. Yeah.
Yeah. This problem should be ON because N is 1 million.
But time limit is 6 seconds.
Oh, sorry. So sorry. Yeah. Time limit is 6 seconds. Yeah. Actually, so it's ON 6 seconds can give us about 5 billion computations, I guess, roughly speaking. 5 billion
Oh,
computations.
so then we
Oh wow,
start.
interesting. ON square could work, yeah. No. ON square cannot.
Yeah, of course
Yeah,
not.
yeah. So
Brackets. That's limit.
yeah, but I think the time will be already spent by checking the characters one by one already. This stack push and pop. I think it will eat up a lot of the time because each string can be 10 to the power of 7 long, right?
Yeah.
Each string can be as long as 10 to the power of 7,
Oh,
and
that's
there
10 to the
can be
power of
as many as a million tablets. So just processing the characters is already very taxing. Yeah, that's why it's 6 seconds limit. Yeah. So I think it needs to be ON or ON log N, or yeah, ON square definitely cannot. It has to be ON or maximum ON log N. Oh, you're using pair now. Okay.
yeah, because when we want to sort, we
Oh yeah. Okay, makes sense.
okay. Sum plus equal AI dot OP minus AI dot CL. That then now we just want
So line 89, mas. Line 89, if you want to be greedy, you have to start with the largest open, right? Line 89. Line 89, if you
yeah
leave it like that, you will start with the latest tablet, the last tablet that has no closing.
last
That has
tablet that
no,
has no close.
right?
Oh yeah. No, you have to start with the last tablet that has no closing, right?
No, last tablet in the input. You don't have to. If there are multiple tablets that has no closing, you would want to start with the largest one, with the longest one, with the largest. Yeah.
Dot op.
So you have to
Okay.
put an if statement of start. Start needs to be not equal to -1, right? Yeah, right before that, right before this statement.
Starts not equal -1.
Yeah.
And
Yep.
but
That is okay.
if no, this is not
That
okay.
works.
If
That
start
works. The moment it fails, it will stop the logical calculation.
no, but
You know that, right?
starts starts with -1, right? So start is never -1. It
What do you
starts with
mean?
-1. So start starts with -1, which means that start is not equal to -1, which means that this will be false. And because these are all n functions, this would be false, and this wouldn't happen, and start will continue to be -1, making everything impossible. See?
Oh,
So you have to say n start equal -1, or this. Supposed to, oh wait, no, yeah, just minus, just change to or. Yeah.
oh yeah, you're right. Okay, good.
Then what happened? Oh yeah, then now we sort. Okay, then if we sort, we don't even need start, except for impossible. Oh yeah, we do need start. So then we sort the a plus n. Just use custom comparator. I don't want to use lambda. So bool comparator of PLL A and PLL B. We want it to be greater. So return a dot cl minus a dot op. We want the start to have as many OPs as possible. Return. Oh, this becomes a problem then. Oh no, it's not a problem. A dot op greater than b dot op, but we have to find the difference of op and cl. So a dot cl greater than b dot cl. But if they're the same, what happens? If they're the same, then we compare the actual OPs, right? Yeah, then we compare the actual OPs, or no. So LL x equals to a dot op minus a dot cl LLY equals to b dot op minus b dot cl. Then if x equals to y, return a dot op greater than b dot op. Else return x greater than y. Yeah, so now if we start, oh, but it also has to start the index. So
Map.
map,
No.
no, map will be too much. You'll have to map every pair to the index.
No, you just add one more then in the pair. Like make it a
Yeah, I
tuple.
think PLL pair of long and pair, or you could just create a struct. Yeah, we could just create a struct, much cleaner. So struct node like this. Struct node LL
Tablet
closed,
actually.
LL open,
It's
LL.
called tablet is the problem.
Okay, fine. No, tablet's too long. We don't even need to write it anyways. You just have to initialize it.
Okay.
Then we won't
Okay.
have
Yeah.
to use it anymore.
Yeah.
So this will be A N, yeah, not A N. Then also the index. Yeah. Where was it? Where? Yeah. A AI dot index equals to 0. Equals to I. and dot op is equal to 0. We cannot do this anymore. I don't know if it works. Op equals to 0 equals to ai dot cl equals to 0. Oh, that is a long error. Wow. Okay, so if we try each x a cout x dot int plus 1 x slash n.
Backslash n. Yeah.
This now 31524. Wait, there may be multiple answers, right? 1, 2,
Yeah,
3,
there
so
could be multiple answers. As long as your answer is valid, then it's okay.
5,
31524.
2,
3
4.
1. Yeah, 3 1 and yeah, 3 1.
No, this doesn't work. This
Yeah,
doesn't
it's the
work.
same thing. It works. Yeah, it's the same thing.
No,
Submit.
no, it doesn't work.
Huh? What do you mean? 31524 is valid. What?
No, it isn't. I checked with the whiteboard.
3115.
I drew it on the whiteboard.
No, it's valid, mas. Coba
It
draw.
is?
Okay, throw it on the whiteboard.
I did.
3 is what? 3
This.
is 2 opening bracket followed by 1 opening bracket. Yeah, that's not closing, mas. That's opening.
Oh.
Check the problem.
Oh.
Yeah,
Ah.
it's valid. It works. Submit.
Wait, let me try.
Yeah.
Wait, I need to double check. 3, 1, 5, 2, 4. Did I make a mistake somewhere? Oh yeah, it is valid. Yeah.
Yes, it is valid.
How do I
Okay,
submit?
submit. How do you submit?
H, right? H.
Submit. Itu
Submission.
ada
No
submit on the top itu. Itu on the top, there's a submit button on the top.
ICPC prehistoric programs. Not CC. Not CBP. H. 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 Submit. Okay. Oh, let's see. Wrong answer.
Wrong
What?
answer.
Immediately.
Okay, let's see.
Hi, this.
That's it. There's no explanation. There's no nothing. uh,
Wrong answer.
but all the input test cases valid, right? Okay. Why is it wrong? Greedy.
Greedy doesn't work.
Greedy should be all right.
Okay, what test case makes this?
Oh no, mas. You just sorted everything, mas. You have to start from. I.
Start. Oh yeah, I have to start from start, right?
Yeah, you have to start from start. Sorry.
So
You just sorted
so what?
everything, so it doesn't work.
Swap start. Swap A0 and A start. Then I swap A plus 1, A plus N comparator. Yeah. Okay. Does it work now? Yes. Save, submit.
Okay, that's an interesting solution. I did not think of it. Okay, that's good.
Hit. Yeah. Oh, it's taking some time.
Because the assumption is if it works. Oh, wrong answer.
Okay, that means something this way.
Okay,
What
show
is
me your
it?
sort. You are optimizing for the delta, right? You are optimizing for the difference, right?
Yep.
If it is the same difference, you want. Actually, it doesn't
Open.
matter, right? If it is the same, it doesn't matter really, right? Oh no! If it is the same as, you want the smallest. You don't want to minus to negative. You actually want the smallest.
Smallest open or close?
Opening. Sorry, smallest closing.
Close.
Yeah, you want the smallest close.
Does it matter?
Yes. Change line 52. It should be A dot CL smaller than B dot CL. Yeah, coba try. Yeah, try submit this.
Submit.
Because you want to avoid minus scenario, right? Whereby you don't have enough opening. That's why you want the smaller closing as possible. Actually, in fact,
Ah,
it should be also the case even for the other also. You need to prioritize the smaller closing first. Yeah, actually. So even your else, or maybe the whole thing, yeah.
you want written smaller? You want the smallest closing or the margin
Yes, you want the
difference?
smaller closing. You want the smaller closing, and then if the closing is equal, then you want the largest opening. The larger opening, yes. That should be your comparison. Coba. So
So
if it is equal,
we want the larger
closing.
opening.
What is X? What is Y? You haven't. Yeah.
A dot equals to B dot
Say yeah. So if it has same number of closing, you want the more openings. Yeah. Okay. Submit.
Hmm. Hmm.
Yeah. Because we must avoid a case where we don't have enough closing in our balance.
Four tries.
Okay. What if you just sort everything aja? So just now you swap, right? You don't even need to do that. Maybe this will make you start with the most number of opening, no? Or is it not?
Yeah, most number of opening, right? AI dot open greater than A star.
No, no.
Yeah,
Scroll to the top. Sorry, scroll to the top.
you want smallest close. Hmm? But there is no close. So opening, you want the most opening.
You want to work with the smaller closing first. Yeah, you want to start with the smaller closing first.
Can we increase the how do you choose? Start.
Coba remove the unnecessary function itu. GCD and P is your template, right? Yes, we're not confused. So, is there something wrong with your stack processing? Are we sure with your stack processing? Should be, yeah.
Should
If it's
be.
empty, you push. If it is empty, you push and then continue. What if there is only one character? What happened? Oh, and then you process, yeah. Okay, okay. And then
Yeah.
afterward you process. So push current and then push ch. I see. Okay. Okay, makes sense. Okay, this works. Okay, looks okay. Um, yeah, scroll down.
Down.
Um, we check sum is impossible. If start equal to -1 or start equal to -1 means ini ya. Yeah, start equal to -1 means means impossible because we haven't found a single tablet that has zero closing.
You always want close to be at the back. You want a lot
Yeah.
of close at the back, and in the same you want a lot of open. Having a lot of closed at the back isn't. Shouldn't it
We
be
are already started from.
shouldn't it be written a dot cl minus a dot op smaller than b dot cl minus b dot op, right? Because just because you have a lot of if you have a lot of closing brackets, what if a dot op is greater than a dot cl?
Yeah. Yeah. Okay. Try that. Try.
A dot, then if a dot cl equals to b dot cl,
You need to also say if it is equal. If it is equal, you return. If it is equal, this minus. So no, 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 no. You need one more line. One more line between 50 and 51. Yeah. If what you're checking downstairs down there is the same. So a dot cl minus a dot op. Yeah. If it is equal to that, then we prioritize the smallest.
smallest closing.
Yeah, return the smallest closing, correct.
Return a dot cl smaller than b dot cl.
Yeah.
No, sorry.
Okay, submit.
No.
Still wrong answer. Actually, when you download the submission, does it give you any hint? Try to click that. Yeah. What do you get? Is it just your file?
Just my file.
Your file. Okay, okay. But it's useful, I guess, for team who doesn't keep track of the code, which most team will not actually. Yeah, useful. Okay.
How would they not?
Okay, let's go back. Let's see what is missing here. What is the test case? What is the scenario that we don't anticipate here?
So this is saying if they're the same, we want to have more opens at the front. If a dot cl minus b dot op equals to b dot cl. That is the difference is the same. If the closed is the same, then we return a dot op greater than b dot op. We want difference. No, it's not actually difference.
You already start with the tablet that doesn't have closing and have the largest opening. You already start that way. You already start that way. And then you sort everything else according to the greedy, whereby we want to. Oh, nggak bisa juga, Mas. So, yeah, I think I know. The problem, the scenario that we miss. So sort of we have to combine the two needs, right? We have to make sure we never having negative balance, right? You know what I
Yeah.
mean when we say negative balance.
Yep.
But at the same time, also we want to optimize for the what is the extra balance we get after this operation. So your logic there in the comparison, right? Line 52, that final logic optimizes for what do I get after this, right? Because you
Yep.
check
Yep.
the delta. But then we are risking that it may be negative,
Oh yeah. Yep. Yeah.
right? So let's say, right? So let's say you start with only 5 open brackets, and then you are given 1,000 closing bracket, but 1 million opening bracket. Because you are greedy, you will take this up, but you don't actually have the balance to do that, right? See what I mean?
Yeah. Yeah.
So that's why I prefer to optimize for the smallest closing first. But that optimizing for smallest closing also give us a situation where after that we may not have enough opening as a balance, right?
Yep.
So let's say it's all just closing, and then we run out, right? So imagine
Yeah.
if so many tablet segment yang just one closing, so many. And even if we start with 1,000 open brackets, but if we have 1,001 of such tablets, we are dead. And the sorting will optimize for this, right? We will start with this. But instead,
Yeah.
we should have allowed for two closing that give us, let's say, 1,000 openings. You see? So how does this work then? It's okay. So what is the right algorithm to solve this? You
Deep.
TP, yeah? Is it TP?
Two-dimensional deep.
It's knapsack, right? It's knapsack. No, it's not knapsack. Sorry. Yeah, knapsack is also DP. Yeah, maybe it's DP. So basically, you have two constraints. One is you have one constraint and you want to be greedy. The constraint is you cannot run out of negative. You cannot run out of opening brackets. That's the
Yeah.
constraint. Die cannot. And as long as you can, then you want to increase your balance. You want to increase your opening brackets, right? So it's like you have money, right? You have money, and you have money to begin with, which is your start, and you have so many transactions that you need to do one by one, right? You want to make sure that for every transaction where you have to pay money to get money, you don't run out of money.
Oh yeah.
And as soon as you don't run out of money, you want to prioritize greedy, right? You want to prioritize transaction that gives you more or the most extra money after the transaction is performed. So
Yeah.
yeah, yeah. So how do we do that?
What if we sort them separately? No, it won't help. Would it help? Maybe we could have a prefix sum of the current, like yeah. Could we have like a prefix sum of? We have a prefix sum of the
Is
or
this
the
like
value.
priority queue? Yeah. Is this like priority queue?
Priority queue.
So yeah, priority queue. So we want greedy, right? So we
Yeah.
want to take the maximum delta, the maximum extra money to get. So imagine that it's a max heap. Imagine it's a max heap. Priority queue is max, yeah. Max or min? Max, right?
Max
Priority queue is max, right? Yeah.
default.
So yeah. So we want the maximum difference, right? But then when we take, we are greedy, right? We check first. Can I afford this or not? If I cannot afford, then I put it in a separate put it in another priority queue, I guess. Or stack. Yeah, stack, right?
Yeah.
Or another priority queue that prioritize that there is a min heap. Yeah, I think it's like that. So you need two priority queues. One is max heap, one is min heap. The max heap optimized for the delta, line 52 basically, right? That line 52 that you have, right? How much extra money you gain after this transaction. And the other one is to store those transactions that we cannot afford yet. We want to put it as a min heap, like how much is the cost of this transaction. You get it, right? So it's like you have many transactions that you can choose from. You want the transaction that give you more extra money. But if you cannot afford it yet, you want to put it in a separate priority queue that is sorted by the cost of the transaction. Like in this case is how many closing bracket it has. That would be the cost of the transaction, right?
Yeah.
Yeah. Yeah, I think it's two priority queue. Yeah, I'm pretty sure it's two priority queue. One is max heap, another is min heap. You get the idea?
Yeah, I get the idea. Basically, just storing the transactions for later, right? Oh, okay.
Can we use a custom comparator for the priority queue? We can, right?
We can make it a mini heap, and then we can have it as a specific like pair of
No,
long long and long.
just use the same node, right? Just use the same node structure, but the priority queue
Oh,
we
yeah.
use custom comparator.
Yeah, you can.
Coba
You can.
try Google it. How to
You
priority queue C++ custom, yeah, custom compare.
yeah. Oh, class. Why didn't
Oh,
don't
so
eh?
complicated, eh?
No, just same thing as a sort. Same thing as sort.
Yeah, lambda, right? Oh, doesn't have to be lambda also.
You don't have to be lambda.
Yeah. Um, Let me also go C++ priority queue custom comparator.
Oh,
Yeah, it's the same. It's the same as.
the which one? The class.
So when you create the try go back and go back in the Google search. There's one. The second one. Yeah, this one. The neutral font. Yeah.
Neutral photon.
Oh, this guy looks like Indonesian. Who's this guy? Neutral photon. Anyway, yeah. So yeah, see, you can just declare the priority queue over there as you see. Priority queue int vector int, and then you pass in the custom comparator. Yeah, it's easier that way, right?
Yeah. Okay. Oh, so use lambda, basically.
So like if you want a min heap, it's as simple as just putting greater.
Yeah,
Is it not?
yes, it is as simple as putting greater, but the problem is we are using node, right? It's a struct. It's not a pair, so I do not know the behavior when we use greater for node.
That's a good point. Okay. Okay, up to you. So maybe you just use the traditional way, like use the traditional data structure, right? Like pair, whatever. But you get the idea, yeah. So we have two priority queues, yeah.
Yep.
This reminds me to some other problem last time. I think we saw something. Oh, median heap, median heap using two priority queue.
Do we still swap the? Do we still put the start? Do we still start with start?
Yeah, we have to, right? We
But
have to.
start, yes, we have to. We have to start with one of the possible start, but the option for start is the one with the most open brackets.
Yeah, that's the best. It's greedy. It's the greediest. It's like you want
Yeah.
to start with as much money you can, right?
Yeah.
Yeah.
Oh.
And then instead
So
of sorting, you have two priority queues. Two priority queues. One is to store the extra money, extra opening brackets that you have, and another is to store those that you cannot afford yet, right? Oh yeah, it works just now. The min heap just now. See, the AI
yeah,
actually
yeah,
helped you, right?
yes, but it doesn't work. Like I said, it doesn't work. Node doesn't work with node. Yeah, this works. If only. But what do we want to put in the priority queue? We don't need to put the whole node itself,
Pair.
right?
Yeah, it's just a pair.
Yeah, we just need pair.
Pair. But also you will need index. So it's actually pair of pair and long.
Pair of pair of node. I still want to
Okay,
use
let's
node.
remove. You still no, we don't need, right? In this case.
Alright. Okay. So type def pair of pair and long is the new node.
Okay. Can.
Which means
Yeah.
that
Yeah.
this C, all this is C, converts into all this is no, this should be dot C dot C. Then this should be dot C. Yeah.
Okay. Actually,
Oh, I
your
forgot.
index plus one, you can do I plus one already when you read the input also. And but up to you is okay. Zero index, yeah. Yeah.
Hmm. Phi dot
You can
phi
compare. Oh yeah.
Phi dot C. Then int was int. It's just dot C. Okay. Then now these are all nodes. Vector of node min heap. Yeah. Then how do we do this? So we input everything to the max heap. We input everything to the max heap, right?
Not
And then
everything.
after
Everything excluding A0. Yeah.
yeah, everything including zero.
Yeah.
Yeah,
Okay.
everything including zero. Then we look through it. So while not max heap dot empty, we get the current. Yeah, max heap dot top. Then we pop max heap dot top. Then what do? We check. We find the mean heap, right? We check, is the current mean heap the top, is it enough? Can we use it? Can we have that? Right? It is. So we get the mean heap. Then how do we
Yeah.
compare?
So you check first. Do I have enough money? Now
Yes.
the amount balance. Maybe you just say balance. You start with balance, right? Balance is A0 dot what? No, it should be before your processing of Maxip, right?
Oh, the current balance. So
Yeah.
LL balance equals to A0 dot it should be dot, is it closed? Open or open. So dot fee dot fee. Let's see. Fee dot C, right? Yeah, same thing. Okay. Oh, fee dot fee. Wait, what? Uh,
So you put open first, is it?
yeah, it shouldn't be like that. Open temporary. Fee dot C, S dot fee dot fee, then dot fee dot open is dot fee dot C. So close this first. Close this first, which means that this should be dot fee. Open.
Okay. Close is first or open is first. You
Close
need the
this
open,
first.
right? You need the number of open.
Yeah.
Okay. Right. Yeah. So that's your balance. So now you have to check: can I afford this? Do I have enough balance to take this? If I cannot, I put it to the min heap, right? That's how it works, yeah?
Take. Oh. Then when do we use the min heap? We have to check the min heap also, right? We have to know. We have to push it to the min heap and then check the top of the min heap.
Yeah.
We don't check it first.
We have to check the top of the min heap first, gitu, yeah, you mean?
Yeah, we push it to the min heap and then we check.
Oh,
What
yeah,
is
we push it
the
to min heap and then we check. Yeah, correct.
so min heap dot push current, right? Then
Yeah.
if we can afford many transactions in min heap, do we use all? Do we do all of them?
Yeah, of
So
course. While you can afford. Yes.
while
While min heap not empty.
and well, no.
And balance greater than or equal to. Oh, no. You okay.
Just we cancel. Just that we cannot see this. So while it's still not empty, we can what do? We check. The balance is the number of
You can
close.
just say, yeah, you can just say dot top, right? While min heap empty and your balance is greater or equal to min heap dot top
Yeah,
something, right? Greater than or equal, yeah. Min heap dot top what dot, is it first or
closed, right?
second?
Close minus fee.
First dot first fee dot fee. Yeah.
Only
Yep. Then you can afford it, then you just do it. Then you pop it, right?
while minus equal min heap dot top dot fee min heap dot top.
Wait, you need to also plus the SE. So balance is
Oh,
now updated with, yeah,
min heap dot top
yeah.
dot fee. Wait, then isn't
Dot
it
fee dot c dot fee dot c dot fee dot c.
fee dot c? Yeah. Don't
Yeah.
we have to? Then doesn't that mean that we have to check, does balance afford min heap dot top dot fee minus min heap dot top dot fee dot c, right? Because when we only count the closed, we might go negative, but when we have the dot fee dot oh no, Oh,
yeah. Now you have to
No, it's like this. If we go negative, we can't fix it.
So actually, Mas, what you should have done is you check current first, whether you can afford current between line 105 and 106. Before you decide to push to min heap. So the logic is we want to be greedy first, right? If we can afford, we want the largest balance possible.
Yep.
So that's what you want to do first. If you cannot afford, then you put it to min heap. So you process min heap only after you check you can afford current. So that's why between 105 and 106, you need to first check, can I afford current? If I can afford current, I want to take current. Because that's clearly the largest I have. Or is it not? Or not really, yeah?
Not always. That's why you push first.
Not always, yeah. Okay. Okay, but let's try that first, yeah.
This one. Or the pushing. Or the checking before.
Okay, so now you have two tops, right? Basically, right? The max heap top, which is greedy, and the min heap top, which is things that you couldn't afford before, but it was actually greedier. Oh yeah, then yeah, you're right. Sorry, Mas, you're right. So we have to prioritize the min heap first. You're right. We have to prioritize the min heap, but you shouldn't push. You shouldn't push first. You shouldn't push first. So you move line 106 down after the while loop.
Why should
Or
you
even
not push first? Why should you not push first?
we want to prioritize min heap first, because min heap contains the greedy ones before that you couldn't afford before. So now if suddenly now you can afford, you would want to take min heap first, kan?
Yeah.
Yeah.
Oh.
Gitu. So this while loop actually comes first, and then your 105 you can shift it down, right?
Yeah.
Yeah.
So do we check min heap? Can we afford current now? Do we check that?
Yeah. Now between 109 and 110, you need to check, can you afford it or not? If you can afford, you do it. If you cannot afford, you push it to min heap.
If balance is greater than or equal to current dot p min heap dot dot p balance plus equal current.
That's it. Yeah. Yeah. This is correct. Wow, the AI is so smart.
Yeah.
Oh my God, that is actually correct. Yes, correct. Try execute.
I haven't printed in. Oh yeah, this is sorting. Wait, but
What?
this is just calculating the bar. We haven't done anything to A, have we? Yeah, we just have the priority queue and we just have the priority queue. We don't do anything to A.
Oh yeah. You create another answer lah. You another vector aja. So you know the vector, the answer vector starts with start. Create another vector aja. Answer.
Why do we need to create another vector? Can we just use A? We can use A, right?
Yeah, up to you. You can swap. You wanna swap, is it? What do you want?
Yeah.
What do you
This
want?
one, right? What?
No, leave it. That's all right. That is actually all right.
Yeah. Then now we are. Now what do we do to A? We have the balance and everything, but we are not doing anything to A, right?
No, you can choose not to touch A at all. Now you need to build your answer.
Yeah. Okay, now we use
Which
A
is,
as
and
our.
you're
Okay,
up to
then
you
how
lah.
do we? Yeah, then how do we build our answer? That's it.
It's just a factor. Keep on appending to the factor. You start the factor with start. Just factor of index.
Oh. Okay.
Your C out is answer, not A anymore. Don't C out from A. You forget A. Now it's your answer sekarang. You create a new one aja. So V,
So
the first element of V is start.
and
Yeah.
we don't really need this.
Yeah, actually, yeah, we don't need that. Yeah.
Oh, no, we do. Or
No,
no,
we
no,
do, we do, we do, we do. Yeah, yeah, we do.
huh? We don't.
We do. You do. You do. You do. You do. You do the original. Yes. Leave it. Leave it. Swap. You need to swap.
Can we just check if
Yeah.
it's longer?
Yep. Yep.
And else when he push,
So if
then
you
V.
every time you can afford, no, every time you can afford, which is line 107 and line uh apa itu?
113.
Don't pop yet then. Don't pop yet. You need to push back before you pop.
Min heap dot top dot c
Yeah.
plus
Yeah.
1 minus 1.
Okay,
We
then
do
you
need
have
to-
to push back start +1. Yeah.
Then over here we got PB current dot
Max heap.
c
Oh, current. Yeah.
plus 1.
And then your C out needs to be now the for each X in V. Your C out
XV c out.
and +1. Yeah. Just V. Yeah. It's just X. Yeah.
It's missing 1.
Huh?
Why is this missing 1?
Why?
It's missing
Why are
2.
you missing one? Oh, you need to repeat the while min heap
One more
empty.
time.
Yeah.
We need to
Just
do this
repeat
one
that
more
one
time.
more time. No, just the min heap. Just the min heap.
Yeah, we don't need it, but there's nothing. 3, 4, 5. 3, 4, 5. 1, 2.
Yeah.
This correct?
So. Yep.
3, 4. Oh, I keep mistaking 1 for a close bracket.
Yep. Looks. This
Submit.
looks. Hopefully this is correct. I don't know. If is this still wrong, honestly I don't know what to do anymore. Hey, test first before I submit. Run all.
This looks right.
Okay, yeah.
Yeah,
Okay. So remove the sort also. Remove the
huh?
sort line. Okay, never mind.
It works.
Yeah, test again. Yeah. If this doesn't work, I don't know what else the corner case we miss. So yeah, that's the challenge of ICPC, right? You actually don't know. Ah, still wrong answer. Ah, you don't know.
You don't.
Kenapa?
Yeah. I mean, at least OI, you know which atas you're wrong.
Yeah, in informatics Olympiad, yeah. That's why this is much harder. There's not much hint or where you get wrong or how.
Two
Okay,
try.
let's read the problem. Let's read the problem again. Let's read the problem again. Let's see. What do we miss? Maybe we miss something in the problem.
No. Oh, can it be overflow? No, there's no way, right? Yeah, there's no way it's overflow. It can't be overflow. 10, 6, 10,
So
7.
yeah, the logic that the sum, when the sum is 0, it must definitely be possible. Is it actually a valid logic? Yeah. Should we not do that? The impossible part, Mas. Maybe we remove the impossible part.
Yeah.
Right. Comment out dulu. Comment out first. Let's just comment out this whole thing. Yang impossible. No, don't delete. Don't delete. Just comment out the whole thing aja. Oh yeah, if it is okay. If start is -1, then you cannot do, right? For sure, it's impossible. Yeah.
Yeah.
Yeah. Okay. Let's remove that first, and then we need to cater for impossible, which is when when min heap is not empty. So in your final min heap while loop, right? If you cannot afford it, that means it's impossible already in your final while loop. This one, balance plus equal, right? Balance plus if no
If it is not
no
empty.
no. Oh yeah. Yes, correct. If it is not empty, then it's impossible. See out impossible, else see out the answer.
Yeah, it's
We,
impossible.
yeah, we were making assumptions, right? And I'm not really sure if the assumption is valid. The assumption was if the sum is 0, then definitely it's possible. That was the assumption.
Yeah.
So I'm
Oh, it is wrong.
why is the min heap empty? Oh, balance has to be 0. If min heap not empty or balance not equal to 0.
Ah, yeah. 3,
Yeah.
4, 5. 3, 4, 5. 1, 2. Yes. Yes. This could be the moment of truth.
I don't know. So welcome to ICPC. There's not much hint and you can only hope.
It's a strategy then.
Ah, there's no strategy. It's just hard work.
This is strategy.
Okay, so there's someone asking what is the VS Code extension being used to have test case checked automatically? Can
Oh,
you just show the extension page? It's called
it is
CPH.
CPH.
Yeah.
Competitive Programming Helper. Which?
Competitive Programming Helper by Divyanshu Agrawal. Oh yeah, someone already answered that also. Yeah, I think that's the correct one. Yes. Yep, very useful extension. Okay. Yeah, balik lagi. Let's go back. Aduh, we got stuck. Everything looks correct. Oh my god, what is wrong now? What do we miss? We miss. So I'm being greedy. Okay, let's start from the top. The greedy algorithm.
This this one. No,
Yeah,
no,
we
this
want
is
to
the
start with the maximum balance, right? We want to start with zero debt, right? We want to start with zero debt and maximum balance of money. And we
yeah.
already started with that. Um, and we already push whatever is left, whatever is the rest, we already push it into the max heap. Okay, do you want to Mas just no. We already passed the test cases, yeah. So the max heap logic works, yeah. Max heap will always take the first element of the pair, is it? Even if it is
Yeah.
nested pair,
Yeah. If it
and in this case is how many. Oh my god, the max heap should not be based on that, Mas. Max heap should be based on the balance. Oh my god, we forgot that.
based on the balance. What?
The extra, how much money you gain. We haven't even implemented that. The max heap is how much additional money you gain. That's the idea of the max heap.
Oh,
So in your node, so go up to your node, your declaration of node, right? So node should be uh yeah,
pair
pair
of
of pair. Yeah, I mean you pair this with another number. Just oh, maybe you don't call it node then, call it something else. The first one, the first one, you change the first one with something else. Okay, yeah. Yeah.
which means this is a
And that
node.
value, so when you push, right?
I have to
Uh,
change
do,
it.
do, 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 yeah, you need to
Uh,
calculate, right?
define. open. Define open as first. So open is fee. No, it should, yeah, it's dot c. C dot fee
C
dot
dot
fee.
P dot P. Yeah.
Then hashtag define closed as c dot fee dot fee. Then
Yeah.
hashtag define int id also. Oh yeah, two letters. C dot c. C dot c. Then the first one is hashtag define. It doesn't matter. We can just do the fee.
Doesn't matter. Yeah. Yeah. Okay, cool. So now you need to calculate this one, right? That's ID, yeah. Dot ID.
This is the open. This open. Dot op. Then this is dot cl. This is dot id.
Yeah. And then dot fee is actually open minus CL. Where do you set that? Dot fee equals
Oh,
to
okay, okay. Yeah, mistakes here. Dot fee dot fee fee dot c. Okay. All right, everything works.
yeah, now the delta. You need to define the difference. Calculate the difference. Where do you do that?
Difference.
You do it
Difference.
in the input, right? When you process the input, right? When you create the node for the first time. Where do you create the node for the first time?
Here.
Yeah, so that OP minus CL is the same value that you need to put in dot fee.
So AI dot fee equals to AI dot op equals
Correct.
to
Yes.
something.
Yes. Now you don't need sum actually, right? You don't use sum at all. You don't even need that line anymore.
Yeah.
Sum, you don't need sum anymore. Yeah. Yeah. Okay. Test.
It works.
Okay. Then yeah, submit. So this is the actual submission. I mean, we did not even implement the maxi properly. Yeah. So this is the actual submission.
If even the min heap, the min heap should be correct. Right?
Min,
Oh, but
min
the
heap
min
is
heap,
correct.
no, min heap also follows node, so it also prioritizes the balance. It also prioritizes the
Yeah. Then you
delta.
need to change. Then you need to change the min heap. So when you push into the min heap, it's a different structure. So min heap,
What?
what do you need? What do you need in the value of the min heap? Is
Uh,
the number of closing, right? Only, right?
Only the number of closing.
Yeah, only the number of closing. So when you push to min heap, coba try you like rebuild again. You create a new structure when you push to min heap. Create a new structure
Yeah,
basically.
so
Yes, that's
mini
where you
heap
push to min.
push node node of long and pair. So it's a node. Where is it? Yeah, node of long and a pair of PLL. Actually, we can just do this of pair of long, right? And this is current.cl, current.open, cl, current.open, and phone.id.
Okay, you want it to be consistent, yeah? Okay, up to you.
And
But actually, what you can do is just change aja kan. So this
yeah,
is car, right? Just car, yeah. Just do that. .cl. Udah. Udah gitu doang.
this is
Ya. Oke, submit. Wow. A lot of hard work just for one problem. And this is like the easiest problem.
This is like DNA. Ah,
Ah! What do we miss? Oh my god, what do we miss? Wow. Okay, this is really work final. This is really ICPC. Even the easiest problem that is easy to understand and easy to think of, like we must be missing some corner case somewhere. Yeah, ICPC is all about corner case, mas.
oh, why? If it's all then what is a good strategy for ICPC then?
Hard work.
Is there
There's no. But ICPC is a team of three. Yeah, so 3 people attacking 12 problems for 5 hours. So that's a lot of people, a lot of time, a lot of prints, but there's only one computer. So
one
so
computer?
someone think, yeah, the only possible strategy is you need to think first. After you're very sure of the answer and the algorithm, it's like, and it's almost like you won't get any hint anyway from submitting. So it's once you're very sure with your pseudocode or your logic on paper, then you, hey, can I have the computer? Are you done with the computer? Can I have the computer? And then code. So that's usually the way it works. It's a team of three.
And it hasn't changed then.
The what?
The style has it not changed, right?
Yeah, it has not changed since my time, probably since the beginning. It's always like this. ICPC
Okay.
style. That's why the IOI style and ICPC style are different. Actually, ICPC style is brutal. It's like you are almost there, you implemented the logic correctly, you just miss one corner case. And the corner case could be very trivial case. For example, maybe you forgot that the input includes 0 and you just need to handle special case 0, right? But you just completely missed it, right? You could already implement some massive algorithm that is correct, but you just miss one edge case.
Oh my
Then you
god.
still keep getting wrong answer, wrong answer, wrong answer without any clue. So yeah, ICPC is brutal. ICPC style is brutal. Actually, similar to code forces, right? Code forces is also like that. Yeah,
No, but
code
code
forces
forces
that
they show
yeah,
the case, right? Or is
where
that
you
just the
fail, right? Yeah, yeah. How far along you are, right? How
yeah?
far? Yeah, actually, yeah. Code forces at least give you some hint whether you made an improvement or not. Yeah. This one you can't tell whether we are making improvement or we are actually regressing. Oh my god! Wow. Okay, you wanna take a short break first, and then we attempt again, or we wanna wrap it up and try again next time?
Maybe the latter I have an exam. Maybe I don't know. Which one
Sorry,
is
maybe let's
ah
just take a short drink, just 5 minutes. Yeah, we'll be back in 5 minutes. Let's put a banner. Short break. Short break. We'll
should
be
we
back
should we wrap up or
in
should we have a short break?
again.
Should we wrap up or have a short break?
Yeah, up to you.
I think we should wrap up because I also want to study.
Oh yeah, yeah. You have exam tomorrow. Yeah. Okay, so
Yeah.
let's wrap up. Where were we? The conclusion. Maybe you go through your code, show your code, and run through from the top. What is the approach? What is the logic? Yeah, and then
Oh,
we wrap up.
okay. So the logic is first we have first we input, right, and for each string we go through the string using a stack to find out the number of leading open brackets it has, and yeah, basically find out the number of open brackets it has that is not paired with a closed bracket, and the number of closed bracket it has that is not paired with an open bracket. Yeah. And after that,
Yeah.
we just input that data into the array with
Mm-hmm.
array of node, which is pair of long long, and pair of long long and long long. Yeah,
Mm.
that is node. And we find the start. We find a0, which is basically the string that has the most number. Wait, no, the
Of
string
opening
that has,
bracket
yeah, there has no opening brackets.
has
That's
no
not
closing bracket. Has no closing
has
bracket.
has no closing brackets, that is not paired, and has the largest number of opening brackets that's not paired, because we want to start off
Yeah.
with
Yeah.
a lot
Which
of
is our
opening brackets.
balance basically, right? That will be our
Yeah,
balance. And then number of opening minus number of closing. Yeah, correct. So that will be the delta of the transaction. Okay, so and we push everything to max heap while max heap is not empty.
yeah, yeah. While
Yeah. So we prioritize the min heap first because min heap was max heap that we couldn't afford before. That first, right?
then we store them in min heap based on thoughts.
Hmm. Hmm. Yeah.
Oh no, calendar ID is
Balance equal to greater than equal to current.cl.
let's see. Yeah,
Yeah.
then we
Now, if we already run out of min heap, if we run out of min heap, then now we process max heap. And max heap is if balance is greater than the number of closing, balance plus equal. Yeah, correct. Balance plus equal open bracket minus closing bracket. Okay. Um, yeah. Else we update the value to CL and then we push into min heap. Yep, because we want the min heap to have the minimum number of CL that we can afford, right? Yeah. While min heap not empty and balance. Yeah, while min heap not empty and balance greater than top. Yeah. Yeah. Yeah, the algorithm looks solid to me, looks correct to me. If min heap is not empty, so max heap is definitely empty. Is there a possibility that max heap is not empty after all of this?
yeah. Why
Actually,
would
there
it
is, right?
really?
The impossible
We
case. But that will be time limit exceeded because it will be infinite loop, right? But we haven't really seen it.
No. Why will there be a possibility that max heap would not be empty when what is the
Oh yeah, yeah. Because we always pop, and it's either we process it or we push into min heap. Yeah, yeah. Sorry. So it's definitely empty. Yeah, either we process or we push to min heap. Now we push to min heap. Yeah. Okay. So if min heap is still not empty, yeah, this looks correct to me. I have no idea. I have no idea what went wrong. Do you need to flash?
no? I don't think so.
You sure? Can you flash at the end?
This is not. What is it? Flash.
Because you use the fast IO, right? No, no, no. Leave it, leave it, leave it, leave it. Leave the backslash n. I mean, at the very end of your whole program, before you return 0, you flash. Yeah. Coba.
How do you flash?
How do you flash it out? Yeah. How do you flash? STD out.
Yes.
Yeah, yeah.
We also have to
Okay.
do
Try.
this. We also have to do it for impossible, right? This impossible. The start not equal -1.
Yeah. 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 Does it matter though? Yeah. Does it matter flashing? Maybe not lah. Don't think so lah. Yeah.
No.
Okay. Let's wrap it up. So yeah, we don't know what is wrong. We can ask the audience, I guess. Yeah, well, let's post. I will post your code after this to I think the Indonesian Talkie alumni forum, the Facebook group, and see if anyone can spot the missing edge case. All right. See ya.
Yep.
See you everyone. Thank you for joining with us.